All right, we're going to be looking at exponential equations and manipulating rates from larger increments of time to smaller increments of time. And what we mean by that are gaps in data in time increments. A scientist determines there are approximately 6 million bacteria cells in a petri dish on the first day of bacteria growth study. On the 8th day of the study, the scientist determines there's 48 million bacteria cells in the same petri dish. What function modeled the growth of the bacteria based on days, hours, and minutes? So the first thing we can look for is we can look for a rate, and the rate that we can determine is going to be from knowing that we started with 6 million and we go to 48 million. So we can find a rate. So we're going to do that. We're going to take our last value and divide it by our first value. So 48 divided by 6, which gives us 8. So we've multiplied 6 by 8 to get 48 million. But the thing about that 8 is this is every 8 days. And that's going to be our multiplier for every 8 days. So when we write our first equation, our equation or a function will be based off of the fact that this bacteria is growing every 8 days at a rate of 8. So I'm going to go ahead and start in here. I say y equals to our initial value, which is 6. And then I'm going to have 8, which is our multiplier, our rate. And then we are going to go to the x power. Now, when we look at the percent of change is nice and easy. Remember that a rate, when it's growth, is 1 plus the rate. And if I look at the value of 8, that must be 1 plus 7. And if I change that 7 to a percentage, I take 7 and I move the decimal over, bink, bink, it's 700% growth. So let's go on to the next one. It says, okay, well, let's find it. We want to make this equation based off of days, hours, and minutes. So let's go to days now. And we can work with this. Days. Okay, well, the first thing we need to do is find the rate. Well, we know that the original rate was 8. R equals to 8, but this is for 8 days. So in order to find the daily rate, what I'm going to do is go to the 1/8 power. And that will break it down to individual days. Because the gap in the data was 8 days. So I come over here to Desmos and I say, okay, well, let's go to Desmos. I take 8, which was the rate, and then I'm going to put it to the 1/8 power. And that gives me 1.29. Let's, for ease, we'll just round it to 1.3. So R equals to 1.3. Now this is a daily rate. And I'm just going to write Y equals to our original amount, which was 6, and our daily rate 1.3 to the X. And now that is our daily equation for the bacteria growth, which if we go back to the 1 plus R, I know that that would be 1 plus 0.3. And if I take 0.3 and move it over, it goes 1, 2. It becomes a 30% growth. Now we can keep going with this and we go to hours, okay? We can go to hours. Okay, so the original rate now is we take this daily, we ask ourselves, well, I've got 1.3, which is the rate, and this is a daily. Well, what do I do to make it into hours? Well, how many hours are there in a day? There's 24, and I want one of those 24. So I'm going to come up here, I'm going to type 1 over 24. When I go to Desmos, I'm going to type in, well, let's take 1.3, caret 1 divided by 24, and that gives me 1.01. That is 1.01, which is now my rate. And I can write the equation y equals to 6, 1.01 to the x power. And this is my hourly equation for the growth of this bacteria. In order to find my growth rate for the hour, I just take 1 plus r, and that must be 1 plus 0.01. So I take 0.01, I move the decimal over twice, and that gives me a 1% growth rate. And then finally, if I really needed to go to minutes, we can keep moving this down. I can say, hey, let's pick another fun color. Let's go to brown. Let's go to minutes. Okay, well, I know that the hourly rate is 1.01, and this is hours. So to minutes, I just take 1.01. Well, how many minutes are there in an hour? There's 60. We want the rate for 1 minute, so I just put 1 over 60. Come back to Desmos, I put 1.01. Here at 1/60th. Okay, and it even gets smaller, 1.00016. For ease, we'll just round it to 2. How about that? So I'm going to say, okay, well, the rate is 1.0002 because we rounded it, and this is now the minute rate. And I just say, okay, well, we started with 6. We'd say 1.0002 to the x. And when I need to find that growth rate, I just take the 1 plus r and 1 plus 0.0002. And I just take that and I move that decimal over to change it to a percent, 1, 2. And what you'll notice, it is only 0.02% in percent of change increase for the minutes.